Good morning, everyone. My name's David Martin. I've been leading the Layer 1 Services project for the past couple of years. So we'll delve into the work that we've been accomplishing there and what's going forward. So the reasons that we've started the work on the Layer 1 services, which are often called wavelength services or optical transport services, is exactly the same why Layer 2 carrier Ethernet was started and why IP is underway as well. It's to provide a standard set of service attributes and definitions. So from a different perspective, such as a subscriber, they can do comparison shopping between offerings from different service providers, compare performance specs, for example. For an operator, we are defining an E and an I, so it will allow them more quickly to interconnect their different regions together to provide the underlying service for an end-to-end subscriber service for a service provider. For both operators and service providers, having the standardized set will allow them to market having another set of services which are compliant with the MEF specs, which gives them the marketing benefit of being able to say that. The underlying reason, though, is the same as for why we are doing carrier Ethernet and the IP work, is to bring it under the LSO umbrella so that we'll be able to benefit from the automated configuring processes, allowing the service providers lower OPEX, faster time to revenue, and getting the services out more quickly. So the first spec that we did, MEF 63, came out last summer, describes a subscriber layer 1 service between a pair of unis, so that's the end-to-end connection, equivalent to MEF 6.2 in the carrier Ethernet world. So it provides a point-to-point, bidirectional, full port rate connectivity for a single service uni. There's no multiplexing at the uni. And the same client protocols have to be at both ends. They have to match either Ethernet or fiber channel, for example. And the physical ports at both ends obviously have to have the same bit rate and coding function. So a key distinction here is the entity that's carried from end to end is an encoded block of bits. So that's why we call it a layer 1 service, even though it's maybe commercially referred to as optical. It's actually a block of bits with an error detection code that's transported end to end. So comparing that to carrier Ethernet, you have a frame, and comparing that to IP packet world, you have a packet that's carried end to end. Here it's a block of bits. So at each port, you can have a different optical interface, a different plug, depending on the deployment scenario that you need. So we've defined it using the same groupings of service attributes as for carrier Ethernet. So we have Uni Service Attributes, in this case a layer 1 VC as opposed to EVC service attribute, and endpoints associated with the EVC, the L1 VC in this case. So overall there's only 7, and 5 of those are identifiers. So there's really 2 key ones to focus on, which are the ones I have bolded there, the physical layer and the subscriber layer 1 VC service level specs. So that's the performance metrics that define the behavior of the service. So the 5 there are one-way delay, and then the other ones are all derived from bit errors. So you have errored seconds, severely errored seconds, unavailable seconds, and then availability. So they should be familiar to anybody with a OTN or layer 1 in general transport background. So with only 7 attributes, it should be quicker to do compliance testing for both services and equipment than, say, for a carrier Ethernet, which has well over 30 service attributes. So putting that into a picture, at the left and the right upper sides there, we have the Uni Service Attributes. So there's the Uni identifier. The key one being is the physical layer, which is described by a 3-tuple, where you spell out the client protocol, like Ethernet, what the coding function is, like 8B, 10B, and the optical interface function that you need, like short reach or long reach optics. Then at the far end, at Uni 2, the client protocol coding function have to match, but you can use a different optical plugin for the reach that you need. Then at the lower left and right, you have the endpoint identifiers, which are, again, management indicators. The key piece as well is the Layer 1 VC service attributes for performance, which are in the lower middle there. So you have the SLS spec by start time, a T period, typically a month, and then the PM is the list of the performance metrics I mentioned earlier. So we'll look at a couple of use cases now. Typically, these Layer 1 optical services are used when you have a need for the highest rates, like 10 gig and above, and the highest performance, so essentially zero loss, zero delay variation, and the lowest latency. So we'll look at a couple of cases where we're doing data center interconnect and the extension of 1 to hybrid cloud. So in this use case, the scenario there could be a multi-branch network, say for a bank, interconnected to a headquarters on the upper left. And perhaps the leadership there at the bank has decided for business continuity or disaster recovery reasons, we want to have a backup. We want to have backup storage and computing at, say, a colo site, a colocation site. So they have several options there. They could lease space and power from a colo site like Equinix and drop in their own equipment, or they could lease the computing and storage capabilities from an IT provider who has a offering in that colo, like IBM SoftLayer, for example. Or if it was actually a CSP, a communication service provider building, they could simply lease the three service types that they need, the NIST services, service as a software as a service, or infrastructure as a service. So whatever is relevant for their scenario, they would lease, say, an Ethernet private line if they're doing LAN extension, or they could lease a fiber channel private line out to the colo site to connect to some storage equipment. And then the other little wrinkle is typically there's a backup connection from that multi-point network for the branch sites to connect to the colo site in case the headquarters connectivity goes down. So we'll just build on that story with the web-scale ICP providers now. So let's say Amazon has some massive data center and they want to establish a point of presence in that cloud exchange at the colo site. So typically what they would first do is lease a Layer 1 service from, say, a communication service provider or like CenturyLink Level 3 to get connectivity at Layer 1 from their data center to the colo site. And then in turn, they'd end up leasing like 10 gig Ethernet, SD-WAN, or carrier Ethernet connections for individual services piled on top of that Layer 1 service. So for example, the bank then is maybe making use regularly of their computing that's at the colo site, but then say every 3 months when they need to do their quarterly reports and they need some more computing horsepower, they would lease the typical services from Amazon, typical cloud services, and then they burst through that cloud exchange for the additional computing capability that Amazon has for, say, a week or two until they're done with their high-power calculations that they need to do. So in that case, it would generally be an Ethernet subscriber service. So the other work that we've been working on and have almost completed is MEF 64. So this is the equivalent of the OVCs in the carrier Ethernet world. So here we would have operator layer 1 services, access ones going from unis to EN and Is, and transit layer 1 services between pairs of EN and Is. So for the operator services, obviously at the uni, they're the same set of client protocols because they're providing the connectivity for the overall end-to-end subscriber service. At the EN and I, we've defined an OTN handoff using the O2K rates of 2.5, 10, 40, and 100 gig. So within an access network, you could aggregate access L1 VCs from multiple unis, multiple locations to a single port handoff at an EN and I. And then within a transit network, you could do the same thing. You could combine multiple transit L1 VCs from different EN and Is to a single port at another EN and I for handoff across it. And any given EN and I could be supporting operator services which are from different end service providers. So we refer to that as a shared EN and I. So putting that into a picture, here in the shaded background, we're showing a service provider A network in the top half, and in the light blue, the lower half is a service provider B network. So both of those service providers are dealing with those 4 operators, C, D, E, and F. So in the case of service provider A, it's made an arrangement with operators C, D, and E to provide operator L1 VCs to interconnect Uni 1 at the top left with Uni 2 at the top right. So there's access L1 VC through EN and I2 and into the operator D network to EN and I1. For service provider B, it's made similar arrangements with the 3 operators, in this case CDF at the lower right, to provide end-to-end connectivity from Uni 3 to Uni 4 using a similar set of 3 L1 VCs. So in this case, you'll note that at EN and I2, there's 2 access L1 VCs muxed up to a higher rate handoff. That's what the black circle means, and passed across to the operator D side of the EN and I. So that's called a shared EN and I because you have operator L1 VCs there providing end-to-end connectivity for 2 different service providers. So where we're at with the Layer 1 project, as I said earlier, the MEF 63 document was published last summer. And although it's called Service Attributes, because there are no options for them in that document, inherently it also defines the Layer 1 subscriber service. MEF 64 is the one that will be going to letter ballot out of our meeting later this week for the operator Layer 1 services. And actually it has definitions in there for access and transit services. So it's got the same equivalence of MEF 51.1 in there for EVC, OVCs. And in the LSO committee, work is already completed on MEF 72, which added in the UML constructs for Layer 1 for subscriber services. And work is ongoing to add in the UML constructs for operator services as well. And we're also doing some work on an orchestrated MEF 3.0 optical transport service effort to try and document how the orchestration would fit into it all. So this picture tries to tie together the different specs with the services effort and the LSO effort. So starting in the upper left there, we have our MEF 63 service attributes document, which was then used as the basis for the UML constructs in MEF 72 in the network resource management information model, which was used initially for network resource provisioning, IPS, which needs to be updated to include the Layer 1. MEF 60 has carrier Ethernet. We need to have the Layer 1 version of it. And with those and the ONF's Eagle toolchain, you can then generate the ONF TAPI for the northbound interface on an SDN controller. So just mapping that to our standard way of laying out these different documents. MEF 64 is the service definition that we're wrapping up on. There's ongoing work for the common resource model for layer 1 at the bottom there, MEF 89. And at this meeting, we'll actually start talking about the plans for certification for the different layer 1 services. So future work beyond that, we'll probably start working on service OEM, the equivalents to carrier Ethernet's MEF 30 and 35, and service activation testing. Then we'll need to spin a couple of amendments for the PHYs that have come out of 802.3 of late, like 50 gig, 200 and 400, as well as the higher rates in Insight's fiber channel. And as well, there's the beyond the 100G interfaces for optical in and I handoffs, like the FlexOs for 200 and 400 gig as well. And in the LSO committee, like I mentioned, the NRP for layer 1 needs to be started. And at the Legato interface, which I haven't mentioned so far, is the APIs to do all the service ordering and cataloging for layer 1 services, subscriber and operator. And that's it for me. Thank you all.